Hello everyone. So we are talking about division algorithm. So in the division algorithm, we saw all the examples. We saw a couple of examples where a and b both are positive integer number, and we can find the quotient and remainder for the division where we have two numbers, okay, and one number divides another number. So we say that when we have when we have the following division like b divides a, all right, we can represent a equals to like b times q plus r, okay, where q and r both are a positive integer number, okay, and we saw all the examples where actually a and b are also like integer number. Now we are going to see some different case, all right, some different example where our the value of q may not be same as we saw so far. And now we're going to also give a different definition of the remainder. We're going to say that the value of remainder is going to be between 0 and the absolute number of b, okay. We're going to say some example where a could be a negative number or the divisor b could be a negative number, okay. All right, so the case 1, we're going to see if the number a is less than 0, okay. A is a negative number, so if this number is a negative number and the divisor b is a positive number, okay. So let's find out. Here we are seeing that one example where 17 divides minus 58. So we have to find out the quotient and r for the following division. So we have to represent minus 58 as 17 times one number plus r, okay. And in this case we are saying that in every case actually our the value of r will be always a positive number, okay. So value of r will be, it can be 0, okay, but greater than or equal to 0 but less than the absolute value of b, okay. All right, so here the thing is that we are saying that a is the less than 0, so obviously minus a will be greater than 0, okay. A is less than 0, so minus a will be less than 0. For example, here minus 58, which is less than 0, so plus 58 means minus a, obviously that's greater than 0, okay. So let's find out the quotient and r for the positive for this positive number, okay. So if the value is 58 instead of minus 58, I can represent it like using the divisor 17 times something plus something, okay. So all the example we saw in our previous slides. So in that case this will be 17 times 3, which will give us 51, and the remainder will be 7. So that's our q, that's our r, okay. So q is 3, r is 7. All right, okay. All right, now this 58 is actually our minus a, right, okay, because a is 58, so 58 is our minus a. So we are representing it as like that, minus a equals to qb plus r. That's what we got from here, qb plus r, okay, and q equals to 3, r equals to 7. Now let's find out the q and r for a, okay. A equals to minus 58, so a will be minus q times b minus r, okay. All right, so if we represent it like as a plus, in that case our remainder will be minus, okay, means minus 7. That's not what we want. So what actually we are going to do here, we are going to find out minus q b minus r plus b. So what happens, we are actually doing minus b here plus b here, that is going to cut each other out, Okay, and what actually we are trying to find here, this portion of the number we are going to represent that as a remainder, and that will give us some value b minus r. Okay, so if the value is b minus r, we know that here from that r is less than b, so b minus r will be like some any positive number. Okay, positive number from 0 to some positive number less than b. Okay, so we can tell it for sure that b minus r will be some value which will be less than, which will be greater than or equal to 0 and less than b, right? So that's what I'm doing. I'm adding b here and I'm doing the minus b from here. That will cut each other out, so that will make it like b times minus q minus 1 plus b minus r. All right, so from this positive value here we got the value of q and r, so let's use them. So now that will become minus 3 minus 1 plus b is our 17. Okay, b is our 17, so 17 minus r we got here 7. Okay, so that will give us b minus 4 plus 10. All right, so if a is less than 0 and b is a positive number, all right, in that case we can represent a is like that, represent like that, q times minus q b times minus q minus 1 plus b minus r, where q and r we got actually the value from the a, where a equals to actually a is a positive representation of a. Okay, now case 2, second case. Okay, now a can be positive or negative number, but b is a negative value. A can be any number, positive or negative, but b is a negative value. Okay, it's for example like, let's see, we want to find out where minus 17 divides 58. Okay, minus 17 divides 58. All right, so what will be now the value? Again, we are now using this one just to make sure that r has to be always a positive number. It can be greater than or equal to 0, but it can be greater than or equal to 0, but it has to be less than the absolute value of b. So that means it has to be the absolute value of b 17. All right, so now we are making a proposition that what if b is less than 0? Okay, if b is less than 0, the way to find quotient will be a divided by b and the ceiling function. Okay, so if our b equals to, b is a negative number minus if b is less than 0, all right, then q will be a ceiling function of a divided by b. All right, so in that case actually we are going to represent a equals to like q b plus r. Okay, r will be still between 0 and 17. All right, and q will be like minus q. All right, so still it's a actually valid representation. All right, or we can say that q times minus b plus r still is the valid representation, and the value of q will be ceiling function of a by b. So let's see this example. In that case, if we divide 58 by minus 17, our result is going to be actually if we use the calculator, our result is going to be minus 3. Here it is going to give us minus 3 point something. Okay, minus 3 point something. So if we use the ceiling function here with minus 3 point something, that is going to give me the positive value q equals to 3 minus 3. Okay, all right, So for this result, with minus 17 divides 58, okay, so our Q will be, so we can represent 58 equals to 17 times minus 3 plus R. All right, and in that case the R will be, so we have minus 17 here, minus 17 times minus 3, so okay, that will give us a positive value, and here we are going to find that will give us 51, and remainder will be 7. Okay, remainder will be 7. All right, so here our quotient is minus 3 and R will be 7. Okay, so let's just see another example where we have B is negative number, means B less than 0, and A is also less than 0. Okay, so let's see, A is minus 58 and B is minus 17. All right, so we have to find out minus 17 divides minus 58. All right, so if we find out like minus 58, it is going to minus 58 minus 17. Okay, so our calculator is going to give us a positive value. All right, and it is going to give us a value, a positive number like 3 point something. Okay, and we are going to use the ceiling function. Q is going to be the ceiling function of A divided by B. So the positive, if the number is positive 3 point something, the ceiling function is going to give us the value 4. Okay, so and in that case minus 58, where we can represent it like that, minus 17 times 4 plus the remainder will be actually 10. Okay, so here our Q will be 4 and R will be 10. Okay, so you can actually try to find out all the example. Let me show you all the cases here, what can happen. So the case 1 is just the regular case we saw so far. All the A and B both are positive. So 58 and 17 both are positive. So in that case this is simple. Q will be 3 and R will be 7. Okay, now case 2 is, say A is positive, B is negative. Okay, so in that case we are going to calculate A by B, ceiling of A by B. All right, so that is going to give me minus 3. All right, and this R will be 7. All right, so case 3 is A is negative, minus 58. All right, B is positive. All right, and we saw the examples how we can find that. We are going to actually it is going to be minus 4. All right, and it is going to be plus 10. And case 4 is minus 58, and this is also negative, minus 17. So here also we are going to implement this one because B is less than 0, so it will be plus 4 and R will be plus 10. Okay, always remember R will be, now remember R will be the less than absolute value of B, and it can be greater than or equal to 0. All right, so I'm leaving it for them to practice. All right, so do some practice, and we're going to talk about that in the next class.